Okay, why do we bother? Well, because oxidation numbers enable us to work out what's being oxidised, what's being reduced. So we look at an element in an equation, and if over the course of that equation the oxidation number of that element goes up, it's being oxidised. If it goes down, it's being reduced. So we get an equation like that. Now we just run through and work out all the oxidation numbers. Now once you've done a few of them, you'll be able to pretty much just go along and write them in because they're pretty easy to work out. That's a simple ionic compound, Fe3 plus O2 minus, so that's going to be the oxidation numbers, plus 3 minus 2. Carbon monoxide, we ignore the coefficients of course, they're irrelevant to this. The compound is carbon monoxide, we just work out the oxidation number of it. So oxygen we know is -2, therefore because it's a neutral compound, carbon has to be +2. It's easy enough. This is pure elemental iron, no charge, iron on its own, oxidation number of 0. And carbon dioxide, CO2, ignore the 3 again. Well, 2 oxygens gives us a total of -4, which means the carbon has to be +4. So, like I say, you can run through these pretty much and do them off the top of your head. So, we get our oxidation numbers, then we have a look to see which of them are changing. For which elements do the oxidation numbers change? So first of all, look at iron. Iron starts off as +3, ends up at 0. What's happening to it? +3 to 0, that number is reducing. The iron oxide is being reduced. So we look at the oxidation number of iron itself, we refer to the whole compound as being reduced. And if something is being reduced, as we saw before, that makes it the oxidising agent. What's the other oxidation number that changes in this equation? We see that carbon goes up from +2 to +4. So the carbon monoxide is being oxidised, that makes it the reducing agent. So go ahead, work out those oxidation numbers for everything in all of those equations, work out if and which oxidation numbers are changing for which elements, then use them to identify what's being oxidised, what's being reduced, etc.